That's not.
Stay on the nicest row.
Hey, who was absent yesterday besides Chandler? All right, Chandler, Amaya, and that was it? Okay. Hey, I'm going to collect the homework here in a second, but I want to give the class first. All right, at the end of the class, I'm going to call out the answers, but I want to make sure that the class gets done first. All right. Here we go. So I purposely made this a 2-day class. Nothing new today. Just a quick review of what we did yesterday, but because we had a bunch of absences, and well, they're not back yet, but at least for the 2. So you really got to take notes. This is not challenging stuff. I'm also not going to go into the detail that I did yesterday of proving well, technically they're postulates. I don't need to prove them. I'm just not going to go into why they're true. Right? If you're truly curious of why they're true and you don't buy the postulate, like, wait a minute, is that true? All right, I can show you why it's true. All right, so we're going to do a second day of 4.2. Tentatively, we're scheduled the quiz. We'll see how tomorrow's class goes and make a determination. Usually, when I teach the at-level class, chapter 4, I usually have 2 review days sprinkled in there. So even though this is technically what it would look like if we didn't have a second, so today's a review day. But if we don't have a second review day, then we'll be taking the test after our Columbus Day break. But I kind of anticipate there'll probably be another review day somewhere. Probably not after 4-3, but somewhere in here. This is a challenging chapter. All right, here's your homework. It's just a worksheet. It's about, I don't know, 40 questions, something like that. They're just like, last night's homework where you got a picture and they just basically say, state what the reason why the 2 triangles are congruent. It's like really quickly done. So don't panic when I hand you a big fat worksheet. You're like, oh, it's a lot of. It's not. It's probably about 15 minutes worth of work. Tops. Tops. It might even be 10 minutes worth of work. All right. And just the last motivational speech. Well, not the last, but the only one for today is you got to stay on top of this. You can't let a single day go by where you sit there and you're like, all I heard was wah, 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 right? If that's what's going on, you get so far behind with just one class. Make sure you stop me in the class if I'm showing you stuff on the board that you truly don't understand, right? All right, Danny, put off the homework for a second. Let's go over this real quick. So it was basically 3 postulates yesterday. And this one class, the one class today, we're going to use yesterday, this entire chapter for the rest of the book, like every single day, you will use something that we do today. Okay? And basically it's this question. I give you 2 triangles and I say, why are those 2 triangles congruent? In other words, why do all the sides match up? Why do all the angles match up? There are 4 methods. One of them we don't use, which is method number 1. That's why it doesn't have a name. Method number 1, if you want to show that one triangle is congruent to the next triangle, well, then you got to show that all 3 sides and all 3 angles match up. So basically you show that their corresponding parts are congruent. I don't know how this green one needs to be twisted to match up to that one, but once you do, then you got to pick each corresponding part, left side with left side, right side with right side, bottom with bottom, and then do the same thing for all 3 angles. That's 6 things you have to do after you match everything up. It's a lot of work to use method number 1 to show that they're congruent. So I got to show that all 3 angles are congruent to all 3 angles, and all 3 sides are congruent to all 3 sides. 6 things to do. It's a lot of work. Turns out there's shortcuts, and the rest of the chapter is about these shortcuts. Okay. The first shortcut, Chandler and Amaya, you need to write this down. This is postulate 12 in your book of truth. Postulate 12 is called the side postulate. And what it does, it allows you, there's two different sets of triangles here. It allows you to show that 2 triangles are congruent only by looking at their side measurements. The 2 triangles here on the left, notice that everything matches up perfectly. The left side is congruent to the left side. The right side is congruent to the right side. The bottom is congruent to the bottom. So when all three sides are congruent, it turns out the two triangles are congruent. We can do this with tick marks. We can also do it with actual measurements. Either one is fine. We can also do it with a combination of both, tick marks and measurements. The verbiage for this postulate states that if three sides of one triangle are congruent to three sides of another triangle, then we conclude that the two triangles are congruent. That's a lot of words. You don't want to write that in the proof. So all you write in a proof is SSS. Hey, prove that the two triangles are congruent. Great, SSS. Now, the steps in between that is that you have to show that the three sides match up with one triangle to another triangle. But the conclusion is simply SSS. That's your statement, SSS. There's about 5 of these. Today we get 3, and then we'll hold off on the other 2 as we go throughout the chapter. Okay, so SSS is the first way, well, it's the second way technically, but it's the first easy way to prove that two triangles are congruent. So what is it going to look like? They're going to give you 2 triangles like this, and they're going to state, are the 2 triangles congruent? Chris, are the 2 triangles congruent? Why? Well, there's only 2 tick marks. SSS requires us to have 3 tick marks. Where do we get the 3rd tick mark from? Okay. This is your first leap of faith. What are you going to say, Chandler?
It's the same one.
It's the same. How come somebody couldn't say that yesterday? Why did it take Chandler to come up with the genius statement of it's the same line? All right, this is kind of where we ended yesterday, which was on that one proof, remember? Reflexive property. Hey, this line right here is made up of is one of the three sides of both triangles. It's the same line. Therefore, if I had to put tick marks, I could. 1, 2, 3. Well, there's your 3rd congruent pair of sides for your triangle. So this one is SSS. Can everybody see that? This reflexive property right here is used really often. Not maybe every question, but it's used often. Okay. This is the more easier one. Obviously, if they give you this and you make a mistake on this, I will certainly put your picture on the board and make fun of you if you miss this one for SSS, right? I mean, there's no confusion here for this one. No, I'm joking about making fun of you, but hopefully you don't make a mistake on this one. What did they do to the 2 triangles there? They flipped it, and then they spun it about 90 degrees, right? That's a hard one to do in your head, right? If you turn it this way, right, well, then this side would match up with this side, but then it's got to be flipped 180 degrees over itself. Yeah, that was a hard one to do in your head. All right, the second one, Amaya and Chandler, is called SAS. And it says side, angle, side. Now, you missed the pain yesterday where I had everyone write down 4 definitions. Here's what it means. You have to have 2 sides and the angle in between. 2 sides and the angle in between, except they don't call it the angle in between. Yesterday's people, they call it you wrote it down yesterday. What? The included angle. Included angle just means the angle in between the 2 sides. Fancy words. So it says if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of the second one, then the 2 triangles are congruent. So this is shortcut method number 2. It's called SAS literally because it's side, angle, side. Be careful with SAS. SSS, you're not going to miss that one, right? You're going to see that reflexive thing enough that it's going to be locked in your brain. You're going to miss SAS. You're going to see 2 sides and an angle, and you're going to immediately think SAS. It's got to be 2 sides and the angle in between. So don't just say, hey, I got 2 sides and an angle, SAS. It's got to be 2 sides and the angle between the 2 sides, the included angle, SAS. And it's got to be the same for both triangles. The triangle on the left could be SAS. The triangle on the right could be ASA, and it's not the same thing. They both have to be SAS. That's kind of the point that you'll see today. Yes, Amaya, Chandler? I'm waiting for Amaya. Good, okay. So here's a picture of SAS, all right. Les, is that SAS? Why? I only see a side and an angle.
It's the line thing.
I got another one of those reflexive properties. The two triangles share a common side. Well, if they share a common side, well, that's got to be the same measurement. So now we have an SAS, but it's got to be two sides and the included angle. If instead of this, they give you this side, this is an ASS, right? ASS. Right, that's the donkey one right there. So just be careful when you claim SAS that it is the two sides and the included angle. It's not one of those bad word ones. Okay. Is this SAS? Connor, is that SAS? Why is it SAS? Where's the angle? You just shook your head, yes, it is. And where is the angle that they have in common? Can you tell anything about this angle right here? Like how big it is? No. Can you tell anything about that angle? Can you tell anything about that angle? Can you tell anything about that angle? Can you tell anything about these two angles? What can you tell me? Therefore, they're congruent. So there's your A right there. Since they're vertical, there's your SAS, two sides and the included angle. So this is the second way that they kind of, it's not a trick, right? But the second way they get to a side or an angle, they get to a side when it's reflexive, they get to an angle when things are vertical, okay? The third way, which I don't have an example here, is when something's perpendicular. They'll claim that something's perpendicular, therefore you get both sides of that perpendicular formation of angles being 90 degrees. So you could get congruent triangles that way. And that's usually when they have, it's something like this. It drops down here and you get that's 90, therefore you get that's 90 and that's 90. And that's the third way that they'll, it's not a trick, but it's the way that they hide one of the bits of information that you need. Be ready for that. Is that SAS? Chandler's saying yes. He has no clue what he's doing, so Matt, tell him why he's wrong.
Because it is two sides.
Okay, yeah.
It's only got two sides.
I mean, it's only got one
No,
side.
it's not.
Oh, he's right.
Yeah.
Oh, so you need to apologize to him.
Sorry.
So do I. Now, this one's an SAS because you got this reflexive side right here. S, angle, and the reflexive side they share. Chandler's Chandler's a geometry person. Right? Some people take the geometry really easy. They're like, well, I don't understand. I can just do it. Some people's minds work that way. All right, the last one is ASA. So ASA is two angles and the side between the two angles, except they don't call it between the two angles. They call it, people from yesterday, they call it the included side. But it's the between side, if we wanted to use more friendly words. ASA is two angles and the side in between the two angles. That's ASA. Two angles and the included side of one triangle congruent to two angles and the included side of the second one, and the two triangles are congruent. So once again, just because the first one is ASA, make sure your second one is also ASA. Usually what they do when they're trying to trick you is they'll make one ASA, they'll make the second one, SAS or something like that. You just won't notice it. As soon as you determine it's either SSS or SAS or ASA, it's got to be the same on both triangles. Okay. ASA, yes or no?
Yeah.
Yeah. What did they do to these two triangles, by the way?
They just turned it.
Well, how are you describing turning? He's saying it just rotated. Is this one rotated to match that one? If I turn this one 9 degrees this way, would it match up perfectly? Yeah, so this one's just rotated. Okay, so this one's ASA. You can see angle, angle, and the side in between. Angle, angle, and the side between. That's an ASA. What's this one?
ASA.
Why?
Because of the vertical angle.
Because of the vertical angles, right? So these two angles are congruent. Therefore, you have angle, side, angle. You guys are catching on. All right, the summation to show that any two triangles, at least for today, we're gonna get some more of these, by the way. But for today, to show that any two triangles are congruent, we got these three right here, right? SSS, SAS, or ASA. All right, what you don't have, this is a Mayan channel, what you don't have are the two that you would think that you would have. Well, the first one, right, here's a triangle, and it looks like we have what, side angle, right? Well, let's see if that would be true. The issue is that if you made another triangle, just like this one, right? The problem is that since this angle right here isn't indicated what it is, then I can turn this side and still keep it, I'm still going to keep it 6, but I can turn it this way or that way. If I did that and I extended this line, check it out, I would touch the triangle, the potential triangle in 2 different spots. So I can make a little triangle, I can make a big triangle, and still maintain side-side angle. Of course, they don't call it side-side angle, they call it the bad word. So this is what's called the donkey postulate, right? There is no one, so there is no side-side angle. If you have a side-side angle, the two triangles are not congruent, right? All right, enough of that. All right, you also don't have angle, angle, angle. You got a side, 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 but you don't have an angle, angle, angle. And the reason being is that you could have two equiangular triangles, 60, 60, 60, and clearly these two triangles are not congruent. So you don't have a side, side angle, you don't have an angle, 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 right? They love to throw those in there for examples, both of these. Okay, so try this out. This is from yesterday. This is more for Chandler and Maya. Maya, see number 4? Why are those two triangles congruent? You have 3 options, SSS, SAS, or ASA, or they're not congruent. Because, which one? So you have three answers to this, SSS, SAS, or ASA. So take your eyeball and look at one of those and tell me what you see. And do you see the red markings? So I see, you said you see 2 angles, I see those. What else do you see? Well, you took care of that marking, you took care of that marking. What does this marking mean? Yeah, but what is it referring to, an angle or a side? So read the red markings from left to right. What does it say? That's why. Now you got to be careful, it's got to be the same on both triangles. So you went 1 arc, 1 tick mark, 2 arcs. The other one's got to go exactly the same thing. Hey, 1 arc, 1 tick mark, 2 arcs. So ASA, that's why these two are congruent. Do the next one. Are those two triangles, or are they congruent? Why? It's 3 possible answers, SSS, SAS, or ASA. Now instead of looking at your paper, now look at the board. It's either SSS, SAS, or ASA. What do you visually see right now? Yeah, but how many sides? 1 triangle at a time. How many sides do you see that have tick marks? So I have 2 S's. You got 1 tick mark, right? That means a side, right? Any more tick marks, you got another side, right? I'm not literally counting the tick marks. I'm just saying this is one, that's one, another one. So we got an S and an S. Of the 3 choices, 2 of them have 2 S's, SAS and SSS. So this one, if they're congruent, is either SSS or SAS. Can you tell me anything about the angles? And what you're looking for when I'm looking at angles, you're looking for either vertical lines are congruent. You see any X's there, right? Or maybe you see perpendicular lines. You can tell me something about an angle there, right? Do you see this side right here? What's unique about that? Yeah, all the lines are straight, right? What's unique about that one? Both triangles share that side, right? Literally, it's the same side, but applies to both triangles. So is it the same or different than both triangles if they share a side? It's got to be the same, so I could put 3 tick marks right there. So now what do you have for each triangle? You're just going to read what the tick marks say. S, is this an angle or a side? So all I'm looking at, and I drew this in black, all I'm looking at is the red parts. Side. So they are congruent because of SSS. Now it's got to be for both triangles. That's all I'm doing. That's all we're doing. And there's only 3 possibilities right now: SSS, SAS, or ASA. So this one's congruent by SSS. All right, this is the tricky one. What do you have immediately on each triangle? So I either need another side or I need an angle, SAS or SSS. I can't get ASA out of this because I don't have two angles here. Can you tell me anything about that angle? Can you tell me anything about the side? No. Remember here, because they share that side, we could say, hey, they're congruent to each other. Can you tell me anything about this angle and this angle? Therefore, they are. So therefore, I could put an arc right here saying, hey, they're congruent. Now read. That's why they're congruent. You kind of catching on? All right. I got 20 of them tonight for homework and the answers. You're going to get this. All right. Chandler, why are these congruent? Where do you see a side angle side? Remember, if it's side angle side, it's got to be the side, and the angle in between them. They're not congruent. This is donkey. Okay, that's enough. Stop! Oh, I'm already giving away the answers. I got to leave it there. Okay, notice, and this is what I said you're going to get tricked on. You see 2 sides and an angle. You want to say SAS. But if it's SAS, then it would have to be this angle that has the arc on it. And it doesn't have anything. This is angle side side, right? Don't show your donkey. Get it? Chris gets it, of course. Matt finally got it. Okay. Maya, read the tick marks. So you really want to put SAS, right? But now read this one. I'm going to make her curse. What did you... Attention. So be careful on both of those. One of them will be SAS or SSS or something. The other will be different. They got to both be the same in order to conclude that they're the thing. And this one, the one on the right there, is clearly that one. Why did I do this? If I just made the clip a little bit shorter, it's actually a 30-second long clip. And I did make it a little bit short. Okay, last one. Amaya, what do you see? What can you tell me about this side? It's the same. Now you catch on because it's like that. So we do have on the bottom triangle an SAS, but what do we have on the top one? I made you curse again. Look at him. All right. All right. So don't stop. Don't do that. All right. The next thing is just more of a review of section 1, and that is I'm going to give you 2 triangles that are congruent. I'm not going to say, hey, why are they congruent? Right? I'm telling you, they are congruent. You got to have practiced congruency statement. All right, Caleb, tell me the name of this triangle on the left. You get to name it. Don't say it's Fred. So he wants to call it triangle ABC. He has a choice. He can give me any 3 letters and any combination he wants. As soon as he says that, we are fixed to that. Now we got to match things up. Connor, A goes with what? You said G? Okay. B goes with and then therefore there's only 1 letter left, which is H. There you go. Now you're going to see answers on the worksheet. If you don't choose the way they write the first triangle, yours is going to be different, but you can still match things up. Okay, A goes with G, B goes with F, C goes with H. Anybody lost on that? I think I gave you, I don't know how many of these to do, right? Do as many as you want until you're sick of them, right? Or do them all, one of the two. You don't have to do them all if you're like, I got this. But do a couple, just to make sure you got this.
That
What?
was on the homework. It still killed me. You didn't say we had 5 proofs.
I didn't give you 5 proofs on the homework. You're looking at wrong homework then. I did not give you 5 proofs.
No, you did not.
No, it was 1 proof.
Yeah, no, we're not
All right.
on 30. We're
All right, up here. Okay,
on. We only got one.
Amaya, which triangle you want, left or right? Left. Now tell me the name of that triangle.
Well, I did it. I did 1 proof.
EZY, easy. Nice.
I guess I'm saying this.
Yeah,
All right, as soon as she says EZY, then we're that's the order we got to go with, okay? So tell me the other congruency statement. X what? Careful. Yeah, this one's a tricky one because Z has 1 arc and this other Z has 2 arcs. So it can't be Z goes with Z. 1 arc goes with 1 arc. So they're trying to trick you a little bit here. They took the 2 triangles and they did that. They still share the same side, but they flipped it over.
Oh, that's confusing.
It is.
It's no fun.
Everybody good on this or no?
Yeah.
All right, be careful on those. All right, I don't think I have another one. Yeah. And that was it. All right. Worksheets. Don't panic. It's not that bad.
That's not the problem. It's this tedious.
Well, it's practice. Yeah. It's practice. Danny, when you do this, I'm going to take that number next. Make sure you're checking the answers, yes? The answers are in the back. Make sure you check your answers. If you get something wrong and you don't understand why you got it wrong, then you call me for assistance. And say, why is this one this way? I don't see, or you can talk to your neighbor. That's what I'm going to.
Did you last night?
All right, let's go over homework real quick.
No, not.
I wanted to make sure that I got through that class just in case. I didn't think it was going to go that long, but just in case. All right, now we're going to go over homework, which was, well, don't listen to Matt. He absolutely screwed it up.
Yeah, I didn't.
You're 6 pages off.
Yeah, I was 6 pages off. I wrote
You're
down-
6 pages off. That's why you end up doing 5 proofs.
I did 1 of them.
It was 1 through 16 all.
I just, it's the way to do 16. It's all I can. I do this tonight, so.
All right, 16 is the only proof, by the way.
Yeah.
And it's one of those fill in the blank proofs, right? All right, any questions? Yes. The proof.
Yeah.
All right, I'm going to bet that you got number 1 right, which is the given. All right, number 2 says that AC is congruent to AC. All right, we just spent some time literally on that, Bailey. Madison, why? I'm looking at Madison, I said Bailey. And that's why she's looking right back at me. I was like, why is she looking at me? All right, Madison, why is AC congruent to AC? Why is pencil equal to pencil? They're the same, right?
The definition of congruent.
No.
But
Amaya, why is one side congruent to the same side? It's reflexive property. Reflexive says that A equals A or B equals B. And that was the one that I told you. I said, hey, that was chapter 1. And I said, it doesn't make much sense now, but eventually we're going to use it a lot. We're using it a lot. So whenever you have, because remember, Madison, our goal here is to get an SSS, SAS. So you're going to have to eventually get to a side of some sort. And one of the ways is when they share a side, you just put reflexive property. Done. All right. Now this particular one, they broke the given into 2 separate statements. So that statement number 3, AB is parallel to DC, that's part of the given. If I were writing the proof, I would have knocked it out at the very start. So why is BAC congruent to DCA? Madison, I'm going to draw everything but the triangle. Here's the top of the top triangle. Here's the bottom of the bottom triangle. We're told that these two things are parallel. And then you got this line that goes like this. That's the reflexive line. I'm just not going to draw the triangle. This is previous chapter. Two parallel lines cut by transversal. What can you tell me about that angle and that angle? Because, and that's what that one is. Hidden inside that triangle is those two parallel lines cut by transversal. That's why they're. Therefore, you just showed me, and I'll draw the rest of the triangle, right? You just showed me that this is that the right one? AB? Yeah. You just showed me that that's congruent to that. You just showed me that this angle is congruent to this angle. What's the other thing we have? Oh, and then you have this. That this is congruent to this. So tell me what we got here. Haley. There's the markings. Why are the two triangles congruent? And you're done. All right. For the rest of them, 1 through 16, here we go. Number 1 is ASA. I'm not going to give you the triangle congruency statement because there's 6 of them, and I'm not going to go through all 6. I'm going to let you do the worksheet today and get to those. Number 2 is SAS. Number 3 is SSS. Number 4 is SAS. That's one of those ones with the perpendicular angles. Number 5 is you can't tell me anything about them. You can tell me that they're isosceles triangles, but that's about it. Number 6 is your donkey one, so nothing can be deduced on 6 other than they may or may not be congruent, but we can't tell from the given information. Number 7 is SAS, so those are the vertical angle ones. Number 8 is the donkey one. Even though you have vertical angles there, you get ASS. Number 9 is ASA. Number 10, because you got parallel lines, so you're going to get these alternate interior angles. You get an ASA out of that one, not an SAS. You get an ASA. You got a reflexive line, and then you got the 2 sets of alternate interior angles. So ASA. Number 11 is ASA as well. It's the same idea there. You got parallel lines. This one you would get not the alternate interior. You would also get corresponding angles here. Number 12, you can't deduce anything. You just got 2 parallel lines. Now we would get an angle, 2 angles out of it. You get the third angle by the fact that 2 angles of one triangle are congruent to 2 angles. You get the third. Just because the 3 angles are congruent, you can't deduce anything. 13, once again, you get an alternate interior. You get an ASS out of that as well too. Not good. 14 is SAS, and 15 is ASA. And that was it. Das ist alles. Wir sind fertig. That means we are finished. Questions? All right, let me get the homework. One from you. One from you. Chris, homework? Make sure you're doing your homework, Chris. You did. You didn't do your homework because you weren't here. Homework. Homework. Caleb, you forgot all the triangle congruency statements. This was from the previous day. Or were you here yesterday? All right. All right. Do the worksheet. You can get the whole thing done. I didn't need you. Okay. All right, e-learners, any questions? Nothing? So I will stop the video short today of class. We're just going to sit here and do our worksheet. If you have any questions, send me an email. Catch you guys later.